Oh, yeah. No, IOStream should do it, right? I wonder, I don't know why Xcode keeps including stio.h, which is a C thing, really. Okay. All right. So these are one-liners. So if it's a one-liner, it's perfectly safe to make them inline. I'm going to just take them here and make these one-liners inline. If it's inline, I don't need this qualification, employee double colon. Okay? This is it. So these are inline definitions. So basically, along with declarations, right? So these are the two guys that I need to put out there. So because it's outside, I need to say standard colon, okay? Because I'm not doing namespace here, right? Okay, so the setters, I'll do it out of line because it needs to do that validation. So I go to employee.cdp, and I have the setters, say boolean, boot set ID along the ID, and I'm going to say if the ID is greater than 0, actually what I'll do is if it's less than 0, immediately return false. I can't do anything about it. Otherwise, I know it's greater than 0. Now I can do, ID equals the ID, return true. Does that make sense? Okay, so I want to do something very similar to the who set name. Okay, string s. Okay, so if s equals empty string, return false. Else name equals s, return true. Okay, this is pretty much like a template, boilerplate code. You can just type it off the top of your head. Just memorize this. Oh, actually, hang on. This is employee. It's a method, isn't it? So now it knows what the ID is. Okay? All right. Yeah. I didn't realize, since we're going to tape it, I should have picked a more exciting class than this employee. And I could have, if I remembered we're going to tape this, then I would have thought of a more interesting class. Okay, but we'll do employees for them. All right, so we've got the setters, we've got the getters also implemented. We just need to read the two of these. Oh, we need to handle that static global, right? We'll get to that in a sec. Okay, so employee, this is a default constructor, and I'm in the default constructor, we're just going to say ID equals -1, name equals blank, okay? And here, I'm simply going to say ID equals the ID, name equals the. That's it, all right? Now, however, I'm going to do this. I'm going to say, this is something you never do in real life code, is you don't instrument constructors in the production code, right? In your code, in your programs, you have to have a very clear idea of which methods are outward facing and which methods are inward facing, which really is, again, boils down to object-oriented programming, right? Because in object-oriented programming, you have to have a good sense of what you can hide and what you cannot hide, right? Yes? That's what the object-oriented programming is, isn't it? You want to say, I want to hide all this because it's, I don't want to make it complex, right? So just like that, in this code, you want to make sure that these methods, what was I talking about? What is it that needed to be surfaced in that? Well, we'll get to that. So name, okay. So in code, in your classes, you have a bunch of methods. Some methods are allowed to talk to the user. Some methods are not allowed to talk to the user, right? I mean, there's a bunch of tasks. Some is talking to the system, talking to the user, maybe accessing some secret area in the memory. So you may have functions that are allowed to do things and not allowed to do other things, right? So let's just take talking to the user as one of those examples. Every single task that needs to be done in your program, some methods are allowed to do it, some methods are not allowed to do it. Now, in the beginning, when you start coding, most people say, most newbie programmers would say, well, I don't have these restrictions. Any method can do anything, right? Which is understandable because in the beginning, you're just trying to get your program to work, right? You're not worried. You just want to put everything together, see if it works, and then I'll try and fiddle with the details, right? But as you get more experience, you start seeing the value of these things, saying, well, in my function, I'm going to have a bunch of methods, and these methods can talk to the user, these methods can. Why? This is all built around, this is what we do in real life. When you start a company, right, and the company has 5,000 employees, 50,000 employees like Toyota, right? And you can't say that everybody in here in the company can talk to customers that call in, right? So someone calls into Toyota asking, Or you take your car to the mechanic and have it get fixed, right? And you get bashed up or something like that, and you call in and to the shop and say, hey, what's going on with my car? Who do you talk to? You talk to the receptionist usually, right? You talk to the store, you talk to the receptionist, and the receptionist says, oh, I don't know what the status of your vehicle is, but I'll put you in touch with the manager. Who knows? But they're not going to say, or you're not going to call the technician or the mechanic directly, right? Unless you're a close, buddy or something like that. And then call them and say, hey, what's going on with my car? Because those people are not allowed to talk to you. Because, Toyota does not want floor mechanics to talk to the customers because they don't know the details, right? They don't know the cost of the paint that Toyota is ordering in bulk and things like that. So you have these restrictions there for a good reason, right? It frees up the floor worker to concentrate on what they do in the best possible way. So likewise, in your programs, certain methods are not allowed to talk to the world. And the constructor is one of those methods. And setters, getters, these are what you can call internal methods, right? Internal methods are mostly, even though they're public facing, right? These getters are public facing methods, but still they're not allowed to talk to the users. Not allowed meaning, it's not like it's going to fail. Not allowed meaning, Jessica, welcome. Right? Some of the other people are missing, right? Okay, so some of these methods are just not allowed to talk to the users, and you see the reason for that. And setters and getters, they're public, everybody can access them, but they can't talk. They have a very specific way in which they can talk to the user, which is by returning a value, true or false, right? That's the only thing I can do. In my setter, if I say, hey setter, set this ID, -5, right? The setter fails. It cannot set a negative value because it does the filtration. Right? That's what we do here. In my setter, I'm going to say, if my ID is less than 0, I'm going to return false. But instead of false, can I do this? Can I say C out or C error, right? Sending something to the error stream. We haven't covered C error streams. C out, sorry, your set of ID failed, right? Now, I've seen beginning programmers do it this way. They say, well, setter is correct because it returns a Boolean, but in addition to the Boolean, I'm being super helpful by also printing a message saying it failed. So, and especially when you're starting out, many beginning programmers have a sense that it is beneficial to do a lot of talking. It's beneficial to print a lot of material, because it gives you the feeling that programming is doing a lot of stuff, right? Don't do that. Don't succumb to that feeling, because when you talk to the user like this, right? This is extra information. This is actually useless information. It prevents people from building on your code by using your setter. Suppose I want to use your class to build a bigger product, right? I cannot use your class because I want my product to talk to the user my way, but I'm using your setter and you're going to talk to the user all of a sudden. Some random guy's library that I downloaded is going to talk to the user. I can't allow that. I'm never going to use your library. Does that make sense? Okay, so never talk to the user. Never do anything that the user of your library does not expect you to do. If you do unexpected shit, then you'll die in unexpected ways. How is that? Right? So just that's all it takes. It's good sense. Good sense. So don't talk to the user in these methods. But we are going to do this nevertheless right now, just to give you an idea of what actually goes on when I create objects, right? So here in my constructor, I'm going to do the unthinkable, which is to basically talk to the user and say, an employee was created using the default constructor, right? Okay. I'll just put a new line right here. Okay. All right. So I've done that, and let me also do that for the non-default constructor. Okay. Okay. Now I've got these things going. Do we have a static here yet already? We don't. Did we create the static? Oh, we do have a static. Okay. So in my creation of an employee, I'm also going to say num employees plus plus, meaning one more employee has been created every time the constructor is called. Now the thing we don't have is that when an employee goes out, when an employee is destroyed, right, does that value get decremented? Now that's not possible in certain languages like Java. You got to do some really roundabout, convoluted things to get to catch the destruction of an object. But in C++, it's very easy. All I need to do is in my class, I'm going to define a special method. It's the same name as a constructor, except it has this funny tilde sign before it. Okay. Okay. Now this is called a destructor, meaning that every time an object is destroyed, either by you, or by the operating system, or by the runtime system, when an object goes out of scope, right? When the closing brace, then the destructor will be called. So this function will be called then. So I'm going to define that too. So here I'm going to instrument that. So employee colon tilde employee, right? This is the destructor. I'm going to say minus num employees, okay? And I'm going to instrument this too. See, employee destructor was called, okay? Okay, all right. So I've done that, and let's count this destructor. And the one final thing I need to do before I start using this class is that you remember this is a static variable, right? Now in C++, static variables have to be initialized in the code because it's a variable, it's a global variable, and I need to give it a value, and the place to give it a value is here. So I would say long, I think it's employee colon, what is it called? Num employees equals, I don't know, 0. Okay. All right, so that's the way to initialize a static variable. So when the system starts up, my number of employees is 0. Every time I call the constructor, it's going to get incremented. Every time a destructor is called by the system, it's going to get incremented. Okay. So what I will do now is also create a getter and setter for that value because it's private, isn't it? It's private. This is num employees is private. So let me just create a getter here. So long get, not setter, because you can't set the population directly or the number of employees. You can only get the value. So it's going to be static long get num employees return. Okay. All right. So that's it. Now all I need is simply to use my class. So to use my class, I go here, hash include employee.h. Right? Now in here, I can create my employees. So let's go ahead and say employee not employee equals. Actually, you don't do this. In Java, you do things like this, right? In Java, we had a class called awesome, right? Awesome is a class. And you can create an object called awesome with lowercase a. But you've got to do this, equals new. Right? You got to say awesome equals new awesome, right? So that's how we create an object in Java. But here in C++, you can basically say employee, bam. It's called a constructor right there. And it calls the default constructor. You got an object. And you can test it out. So you can say employee, so cout employee. Well, you know what we'll do is also create an output operator. Okay? That would be really cool. An output operator is where I'm going to overwrite the operator itself. So let's try and do this here. I'm going to create an operator. Just to show you that it doesn't have to be done inside the class. Okay? So I can say ostream operator double less than, which is the insertion operator. It takes ostream and as a parameter, which is going to return, and then the operator. So const, what is it? Employee reference. Okay. Now all I need to do here is say as double less than employee ID, and then emp.get ID, and then comma name equals name comma name. Name, and then close up brace, and then this is it, right? And then I return Okay, so I created an output operator for my object so that I can basically say cout double less than my object, and it'll print the object out in this format. Okay. Is this correct? Call to delete constructor of the string. Oh, hang on. Wait a second. What am I doing wrong here? Something obvious and simple that I've completely forgotten. Is that I'm overlooking here. Okay, you're getting past host stream, and then the employee object get ID, and you're sending it to the output stream. It should go now. Okay, all right. So I'm getting the output stream passing by reference, and I'm just passing it back to the user. Right? So now I should be able to do, in my main, I should just be able to do this. Right? I should be able to do employee. Now let's run this. Let's run this and see what happens. Okay? We'll figure out my ways. Oh. Using namespace here. Did I hit Control S or something like that? Hang on. Why is it not doing something absolutely silly here? Can someone, yeah, another pair of eyes, can someone who's done this, what am I overlooking here? I got an error, a binary expression, cout, obviously I can do 5 and that should compile. Okay, so it's just the employee, so it's something to do with something absolutely silly, right? Which I should be able to see and I'm not able to see right now for some reason, okay? So I'm outputting the employee and I have the employee, oh, it's just that I don't have the declaration of this method because it's it is, I declared it here, right? I declared the method, where's my method? Oh, geez. Okay, oh yeah, here it is, sorry. Okay, because this method is here, main didn't know about it. And so let's try and declare that method. Okay. All right, so that's why the error happened is because I defined the method in my CPP file and I was calling it in main, but main didn't know that there existed a function like that, so it was complaining. So I put the declaration of the function in the file. Now main knows that there is this function, and there you go. Okay, so it actually ran and it did produce a correct output. Okay, it produced the correct output right here. So this is the employee. Now let's get a little fancy and say string make a name. Okay. Let's say int length. This is pretty much your assignment, right? So a string vowels equals A, E, I, O, U. I don't know if I threw in the Y. We'll put the Y here. String consonants equals B, C, D. Okay. Is that all the consonants? Okay. And then the last char was vowel equals, let's say, rand. I call rand, and if the rand is less than max rand max over 2. My desktop so that I can delete it easily. Where's my desktop? Okay. Where my desktop is. Okay, all set up. Now, I'm going to do this in multiple files, just so you are comfortable enough going into lab number 7. These multiple files. I'm going to define the class, the pet class right here. Okay, so let's see. New, not pet class, employee class. New file. Where's our new file? and this is going to be a header file, and this header file is going to be called employee.h. Okay. Is everybody watching? Right? Yeah. Stanley and Tyler. All right. So here's where I'm going to create the employee class, and I say class. Okay, that's my template. And in here, I want private, and then I want to have public sections. Okay, in private sections, I'm going to have the variables. So let's say long ID. Every employee has an ID. Let's say string name. Every employee has a name. I think that's enough, right? For now, let's just put it there. And then public would be get string. Oh, not int. Long. Get ID and const. Okay, and then long and a string. Get name. Const. Okay, and then I want setters also. So I'd say, I need constructors. I'll get to the constructors very soon. Okay, so I set bool set ID long n. Okay, bool set name s. Okay. All right. Now we want constructors. I'm going to create two constructors. Okay, I want to construct because I'm going to instrument them and also a destructor. Okay, so let's say employee. Okay, that's my default constructor, and I'm also going to do a non-default constructor. Long the ID string the names. Okay. Now I can give default values to these guys, and as the default value of the ID is -1, and the default name is blank. Now if I do this, I don't need the default constructor, because if I call the constructor without any parameters, it's going to automatically say, the default ID is -1 and the default name is blank, right? So if I do this way, the non-default constructor taking default parameters for every single parameter, then I don't need this. Yeah? And in fact, if you ever create a non-default constructor at all, the compiler won't give you a freebie default constructor. Now, if you don't do this, even if you don't create a default constructor, the compiler will just give it to you for free. But I will create a default constructor because I want to instrument both of those, and I'm going to get rid of the default values here so that it makes sense to have two kinds of constructors. Okay, all right. So are those the only ones I need for now? Okay, those are the only ones. Oh, I like to have a static variable. All right. So static long num employees. Okay. Okay. When I have a static long variable like that, I need to initialize that in the code. All right. So let's see. Now I want to create an employee.cpp file. The source code. This is called the implementation file. Are you getting this? Yeah? Oh, okay. So this is called the implementation file. All right, so I'll just put it right here. So create. So the first thing I want to do is hash include employee.h, right, which is the file that contains the class declaration. And then I'm going to say using namespace standard. Now, typically, when you say using namespace, programmers trying to avoid using namespace in the header file itself, right? Because if you include the namespace, using namespace in the header file, then anyone who includes your header file automatically includes the namespace also, right? So, even if they don't want to. So what programmers would do is in the header file, they would always use explicit qualification like std : and so on and so forth. Don't you say using namespace. In the source file, if the programmer wants in implementation, because that's where the bulk of the code is, there people can do using namespace. Okay, so I think it's a useful convention to remember. Okay, all right. So what are the things that I need to implement? So I need to implement the constructor. So pet : pet. Okay, that's the constructor, and I'll put a small comment here. Default. Okay, and then I want to do a non-default constructor. Okay, this is a non-default. Okay, and this is going to take long VID string. Okay, what else did we have? Pet : get ID. Const return ID. Yeah? double colon get name. Const return name. All right, now you see these are one-line functions. These are one-line methods, right? So one-line methods are perfectly fine. All right, not that employee. Edit, replace. Where's edit, replace all? Oh, find replace. Tesla, right? So you're going to place a bulk order for 20,000 Teslas. And so you send this email to Musk. You can't say, well, here's my list of 20,000 cars, and these are the colors and interior details for each one of those cars. You can't do that, right? This is a pain. When you're ordering in bulk, you cannot afford to specify the details of every single object. Yes, you want generic objects, and let the people configure it. So in that case, then what you have to do is you have to have the default constructor, because you can tell Musk that I want 50,000 Teslas. And he'll probably say, well, if you want 50,000 Teslas, you can give me the details for every one of those. I can customize every one of those for you, right? So the only way you can get 50,000, thank you, Jasmine, all right? Come on over, right? So the only way you can get a billion items of something is by providing a default constructor. Saying that, you can give me a billion items, but I'm not going to be picky about these things. I'm not going to say, these are the exact details of each one of those billion items. That's when you have. So does that clarify? Because some people ask me questions about what's the point of having a default constructor and non-default, and why can't we just have a non-default constructor, and so on and so forth. This was a question in the forums, right? That's the reason. If you want to mass produce something, right? If you want to mass produce something, you need to have a default manufacture process. You can't have a custom. You can't manufacture something. Except these companies like Zazzle, right? Zazzle says, I got a 3D printer. You can custom make things in bulk. But even then, you go and design a T-shirt, they're hoping that not every single T-shirt is customized, right? They have custom. So when you custom make things, use non-default. When you want to, basically stamp out default things. So if I run this, it's going to print 10 lines of calling the non-default constructor. Okay, so let's do that. There you go. Okay, so and look at this other cool thing, right? It not only called the 10 constructors, but when the program exited, which is the closing brace, when the elements in the array went out of scope, the compiler automatically calls your destructor for you, right? So that's the beauty. One of the things I love about C++ is that unlike in Java or some of the other languages, they had to wait for the garbage collector to kick in and pick up your things. This is becoming less of an issue now because we have lots of memory in many of these machines. But back in the day, like 4 or 5 years ago, most machines, 16 gig of RAM was really luxury, right? And you can see, running a Java program, you can see, everything is swimming along nicely, and all of a sudden everything freezes for like 1 second. You've seen that? Have you had that happen? Everything freezes for just a little. It's like a hiccup. Everything freezes, and you say, "Oh my God, my computer is frozen," and then everything comes back to life again. Have you seen that happen? Okay, so many times that's because the garbage collector kicked in and it's running with high priority because there's no room in your memory, or you're recompacting your RAM space or something like that. Something is kicking in. So with C++, you have all of those things in your control. You can create objects, you can destroy object at your whim and fancy. So you create the object, you know exactly when it's going to be destroyed, right? When it goes out of scope, bam, it's gone. All the resources of the object taken by the operating system released into the resource pool again. So all of that happens. You have fine-grained control over these things. Okay, so that's your destructor. See, the destructor got called 10 times. Here, 10 times. Destructor got called right there. Yeah. So now we can print these values too, right? So in fact, what we'll do is for int I equals 0, I is less than num employees, I plus plus. Okay, that's my loop. I'm going to give each employee a name, all right? And in fact, what I'm going to do is max employees, num employees, right? And then const. Okay. Now, all I want to do here is simply say string name equals make a name, let's say a 7-character name, and then string ID equals rand percent 1000, right? So a random number from 0 to 1000, that's the ID. Oh, it's not string, sorry. Wrong. Okay, and then I can say emps of I dot set ID to ID, and emps of I dot set name to name. Is it name? Okay. All right. So I'm going to set these values, and here, and after I've done that, I'm going to print out those employees also. Let's do that. So, and again, another loop right there. Why is it string name? Why did I get an error here? No variable conversion from string to what? Set ID name. Oh, not set ID. Damn. Thank you. So, all right. So this is also something we don't need this. And we don't need this. What I'm going to do is simply print out the names of these employees. So I'm going to say cout employee equals employee of I. And well, let's, for good measure, let's also print the population or the number of employees, right? So you have employee 10. Actually, this is not going to change. We'll just put it here. Okay? Oh, it's not going to change. There, right here. Because 10 employees have already been created. One is printed here. Okay. So employee count equals. Let's run this. Okay, so that's it. So we've created an employee class. We're creating multiple objects of that class, and setting the values of the properties of these objects, and finally we're printing them out. So let's run this. All right. So here you see an employee, this is 10 of those, right? 10. We're going to run this in a debugger too. When you run it in a debugger, you'll see exactly what's going on at each step. Okay. So there you go. Employee count equals 10. Okay. And these are the names of the employees, right? And the IDs, because we created the output operator. Okay. And then the employees were destroyed. Now let's go and create put a breakpoint. Okay. Put a breakpoint here. Okay. That is my, did I show you how to use a debugger in Xcode? It's very similar in Xcode or VS Code or in Visual Studio. They all use very similar, or in Eclipse too, they all use very similar icons for, next step over and so on, the arrows, very similar. So if you know how to use it here, you know how to use it in most of the IDEs. And debugger is one of your greatest friends, okay? I know that the best debugger is a well-placed print statement. Okay, that's what Kernighan said, and it's absolutely true. But sometimes when you get to some more complex code, the debugger is a great help. I'll show you how. Right, so I placed a breakpoint. When you see this arrow, I think in Eclipse it's a circle, a little fill circle. The VS Code, I don't know what. That's also a circle. Okay, I think in Visual Studio, I forgot what it looks like in Visual Studio. All right, so when you see this, it means it's a breakpoint. The compiler will run your code, but it will not run it all the way through to completion. It will stop executing when it heads to this point and wait for your command, saying, okay, now go and execute just the next line. The next line. You execute your program line by line on your queue. Then you can actually look at what's going on and what is supposed to happen. You know exactly where the problem is most of the time, right? So let's run it. Let's run it. Okay, so it's gonna wait. It's gonna. Okay, so this is a debugger prompt, so you don't have to worry. This green line says, I've started running the program and I'm waiting there, okay? So now I'm gonna step over that line. You see number of employees is 0, and how come I have 10 employees already? I'm not supposed to have 10 employees. Oh, So I've got to look more into this. The compiler already initialized this array, right? No, actually it didn't initialize because we didn't see the constructor messages. So what it did was it allocated space for the 10 employees, but I bet the 10 employees themselves don't exist, right? So if I open it up, I bet the employees don't exist. They actually do. They're default employees. Okay, so that's really strange. I got to look into that. Why the compiler already created the employees when the statement has not yet been executed. See, this is a statement. This statement is where the employees actually get created. Yes? Because you can see that. Wow, step over that statement, right? Step over. Okay, now I'm going to step over this line here. Step over. There you go. That's when all the employees got created. You saw that? All those messages? So this is when the employees got created, but even before we got there, we looked at the value of the variable, and there were 10 elements in there. So I got to think more about why that is, but it doesn't matter. Okay, so there you go. Got the employees created. Step over one more time. Inside the loop, I'm going to make a name. Right? Step over that. See, name is now a blank string. Can you all see the blank string here? This is blank, right? This is blank. Okay. I'm going to step over, make a name, assign a value to name. Step over that. Bam. Name became closed rule. Right? So you made the name and assigned it. So you can step over line by line. See? And you can look at what's going on. You can look at the change here. Right? And this is changing. Now, what is the value of I? The I is 4. So the next thing it's going to assign to is employee number 5. So let's open up number 5 here. Okay? So employee number 5 has an ID of -1 and a name of blank. Okay? So let's step over. Okay? And keep looking at this part. Employee number 5. Just keep looking at them, not 0. Okay? Looking at employee number 5. We're setting the values. Okay, it's going to be number 5 now. Beginning. There you go. ID got set to 944. I'm going to set the name of employee number 4. Okay, name got sent to Peggy Doc. All right. So that you can step through the code like that, execute step by step, and see what's going on. Now, when you're done with it, you can always say, right. So run that. You can say, I want to step over all of these lines and get right here. I think you can right-click and say continue all the way to this point, and then it runs all of those lines and stops where you want it to stop. And from there, you can step through it again. So it's a very powerful tool, debugger. You can use it. So you see how these things are happening now. So and again, so I can step through this. I can print out the employees one at a time. Yeah. So each of those employees are being, printed out based on the functions or the methods that we created. Now, is this all clear? So this is the bulk of the functions you'll be using for your Quest. And minor adaptations and variations of this is pretty straightforward and easy. If you get stuck, you can always ask in the forums. But I think we covered that and a bit more information. With destructors, which is not part of your Quest. You don't have to do destructors, and some other things like instrumenting your constructor code and so. That's all to help you to debug and how to use a debugger. That's all we're useful here, knowing how to debug. So this is basically your simple setup. You can start with this template code. Create a class and for your pet, do something like this, which you can knock together in 10 or 20 minutes. Like how long is it taking? It took me about a half hour, but because I was also talking and everything. But when you're working on your Quest, you're going to be on your own most of the time in the library or working with your friends. Yeah, maybe you'll get it done in less than a half hour. Okay, get it done, and then you can just then you read the spec and wire in the other details the spec requires. Right? The spec might say, oh, the number shouldn't be negative, or the name should be 7 letters long, and other things. I don't know. Right? I forgot what the class says, but you can build in all those other things into the class. Okay? So next class, what we'll do is actually, I'm glad I put this in Xcode rather than cpp.sh, because now we have that code. Next class, what I do is take this class, this object, this class, C++ class, and create a massive array on the heap of, let's say, 1 million employees with various IDs, and then we'll implement the search, which is actually a next quest. Right? We'll do a linear search where I can walk into a company and I can say, I want to meet an employee called IDZ, right? So I can say, oh, I want to meet I to Z. And maybe I have 1 million employees and I to Z is like employee number 900,000 and something like that, right? You need to be able to scan your list of array of employees and find I to ZE and return that record to me, right? So I can get the ID and the address and everything else that I need. So we'll do that in 2 different ways. We'll do that using linear search. We'll do some timing experiments to see how long it takes to do linear search a number of times. Then we'll do the same thing with binary search, right? And then you'll see, you'll be mind blown, literally, not literally, of course, right? The magnitude of the improvement you get going from linear to binary is mind-boggling, because we're talking about something that takes a million seconds to run, and turning it into something that only takes 6 seconds to run. What's the difference? 6 seconds versus a million seconds. 1 million seconds is more than 10 days, right? This is about 100,000 seconds per day. This is 86,400 seconds, right? But it's 100,000 seconds a day, so 1 million seconds is 10 days. So you could take something that takes 10 days and say, I'm going to change this little algorithm, now it's going to take 6 seconds. Right? So imagine if you went to a big company who's spending a lot of money doing lots of things, and you told the CEO, I can do this, you can imagine what they'd say, right? That's the kind of cool things you can do. So that's it. We completed the little demo. Thank you. Did you get the whole thing? Yeah?
Yeah.